Now, what do you understand by control unit? The control unit is a component of a computer's central processing unit that directs the operation of the processor. It tells the computer memory what arithmetic and logical unit the input-output devices should respond to the instructions that are being sent to the processor. So now the control unit basically consists of the following parameter. You have the instruction register, you have the control buses, which are bidirectionally uh, connected with the control unit, and control unit is responsible to send out the signals to the CPU. The control unit is also consisting of the different flags and the different blocks that are being connected to the CPU. To the CPU. So the important component of CPU is the controller. The control unit generates a signal for sequencing of operations in the data path. The sequence circuit, which is consisting of the different control signals for controlling of the system. Using status signal and the control input, the sequential control unit determines the next state in which additional micro operations are being activated. Now, control unit is being classified into hardwired and microprogram. Now, hardwired control unit is used to implement to provide a particular digital function. So the digital function is considered to be the function which is faster and which requires less time for execution, and the cost is also less. When microprogram, the control unit binary control values are stored as a word in a microprogram, which is usually called as ROM. Each control unit consists of each word in the control, which is stored in the form of the micro instructions. Now, why micro instruction? Because we want to execute the instruction in a faster way, and we are aware that we are using the nanotechnologies for the execution. So, for the execution of nanotechnology, the instructions are in the form of the micro instructions. A sequence of micro instructions constitutes a microprogram. So you have different sort of micro instructions that together form a microprogram which are being interconnected. Now let us consider the block diagram of a controller. It consists of the instruction register, which is directly connected to the decoder. From the decoder, you decode the signal, you send it to the encoder, and the encoder is connected with the different sort of status flag and the different sort of condition codes. These condition codes are also being connected with the different sort of interrupts or the signals, where the instruction directly goes in the form of instruction 1, instruction 2, and to the signals that are being generated by the decoder. And then it is being linked with the clock and the reset cycle. So what do you understand by a clock and a reset cycle? So that you can reset the program whenever required, and clock is required to calculate the frequency in which the program is getting executed. Now it is also being used to calculate the throughput and also to generate the different control signals which may be required, which may run and which may end simultaneously. Methods for systematic design of a hardwired logic. So hardwired logic is being basically classified into three types. You have sequence counter method, delay element method, and stable table method. Now sequence counter method, it is used to design complex controller of a moderate complexity. Delay element method, it depends on the use of the clock delay elements. So how much time the processor got delayed while processing the particular instruction, and it keeps the generating of the sequence of the control signals which have been connected to it. Then we have stable table method, employs the arithmetic approach to sequentially circuit design using classical and stable table method. So you have to use the stable table method for if you're using the arithmetic approach for a sequential circuit design. Sequential means the output of one instruction becomes the input to the other. So that is a one form of sequence. Now, what are the advantages of hardwired control unit? It requires only 10% of the memory. Hence, the chip area required on the CPU is only 10%. So the cost of this hardware control unit is reduced. It is also used to minimize the cost of the circuit. It minimizes the average number of clocks needed per second. And it is high in terms of efficiency and in terms of the operational speed that has been directly linked to it. Now, what are the problems that are existing with case of a hardware design? First is complex sequencing and micro operation logic. So it cannot be used for complex sequencing because it is difficult to get the output. Simultaneously, it is difficult to test and design. It has an inflexible design. So what do you understand by inflexible design? The design cannot be converted into a static design. And large design turnaround time for complex design. And it is difficult to add more and more instructions that are being connected to it. So more and more instruction becomes a complex task with respect to the hardware design. So in order to overcome this, the software design was being used so that we can operate on the complex instruction, we can reduce the time of the execution, and we can increase or decrease the size of the device accordingly. But the software instructions were little costly as compared to the hardware. Now let us go ahead and look at it one by one. It consists of the micro instructions, which is called a sequencing, micro instruction for execution, and we should consider both micro instruction for sequencing and micro instruction for the execution. So we should consider both of these parameters. So what are the advantages of microprogram control unit? A microprogram control unit is flexible, allows designers to incorporate new and more powerful instruction as VLSI, that is very large scale integration circuit technology, increases the availability on chip area for the CPU. It allows any design errors discovered during the prototype stage to be removed. So if there is any design error, it also allows those design errors to be removed simultaneously. So what are the disadvantages? It requires several clock cycles to execute each instruction during the excess of time, and it occupies at least 75% space on the chip area of the CPU. Now, what do you understand by a monophase or a polyphase? In micro operation cycle, a microprogram control unit implements the sequence of actions into different four phases, what we have seen. In micro instruction cycle is controlled by a single clock cycle. It synchronizes all the clock control signals. Then it is termed as monophase. If each of the phases is controlled by a different phase of a clock, the mode is called as a polyphase. So both of these signals operate in two different modes simultaneously.